Cosine law. Interference due to transmitted light. Consider a transparent film GH G1H1. Now let a ray AB is incident on GH, the upper layer of transparent film. Now it is partially refracted into the film. Let it be BC, refracted ray. At C, it is partially transmitted along CT and partially reflected along CD. At D, again it is partially reflected and partially transmitted along ET1. Let the thickness of film be T. Film is denser medium and this is a rarer medium, right? Now let us extend. This is the normal drawn. This ED in backward direction. Let us suppose that it meets at point I. Okay. Now to find the cosine law, draw a perpendicular from C on DE, angle of refraction. From E, draw a perpendicular on CT. Let it be some EQ, I, angle of incidence. Now here angle of refraction. Okay. Now CT1 and ET1 are parallel to each other. Okay. CT1 and ET1 are parallel to each other. These two rays are generated from one single ray only. So the condition for interference is satisfied. Now let us find out the cosine law for interference due to transmitted light. So now CT travels in the air and ET1 in film it travels from C to D and again D to E, right? So path difference delta equal to mu of path travelled in film CD plus DE minus path travelled in air, that is CQ. Now that is mu CD plus DE minus CQ. Since for air refractive index will be equal to 1. Okay. Now let us find out the value of CQ. For that, from Snell's law, mu equal to sin I by sin R. In diagram we are having these triangles, right? C, E, Q and let us suppose as F, angle of reflection, angle of incidence. Now this one only I drawed. One triangle CEQ, other triangle CFE. These two only I drawed here. First sin I. opposite side CQ, hypotenuse CE. Next sin R, opposite side EF, hypotenuse CE. CE strikes off, mu becomes CQ by EF. So CQ equal to mu EF we got. Now let us substitute this here. Delta equal to mu CD plus DE minus mu EF, right? Now taking mu as common, CD plus DE minus EF. Okay. Now next let us write the value of DE. Now from figure you see DE. It can be written as EF plus FD. EF plus FD. Here I am writing that mu CD plus EF plus FD minus EF. Minus EF plus EF strikes off. So mu CD plus FD we got. Now next we want the value of CD. Okay. So now let us consider this triangle IDC. This one I am considering IDC. I can write CD equal to DI. CD equal to DI. So now in place of CD I am writing DI plus FD. Now next DI plus FD means nothing but Fi. DI plus FD is nothing but Fi. I am writing here. So this is equal to mu Fi. Delta equal to. Now next we want the value of Fi. So to know the value of Fi, now consider the triangle CFI. So here what I am doing? I am considering the triangle CFI. CFI. Here is the angle. So from this what we can write? Cos R is equal to adjacent side Fi by hypotenuse Ci we can write. I am writing the same thing here. Now delta equal to we got mu Fi. Now from that triangle we got cos R equal to Fi by Ci. So Fi equal to Ci cos R. Now substituting mu Ci cos R we got, right? Now we want the value of Ci. So this is Ci. Now the thickness of film we said T. Now we prolonged this only up to I. So this distance will also be equal to T. So Ci T plus T, it becomes 2T. Ci T plus T, it becomes 2T cos R. So delta is equal to 2 mu T cos R. We call it as cosine law for interference due to transmitted light.